So thank you. We have some very exciting demos planned for the next 30 to 45 minutes. We're going to kick off with Palo Alto. Thank you, Hugo, for joining us. Want to quickly introduce?
Yeah, my name is Hugo Perez. I'm solution architect for wireless security in Palo Alto Networks.
My name is Prince Jose. I'm the Director of Product Management for Celona. And first, we are actually going to show a demo with NAC, or the Zero Trust Network Access Control demo. And then we'll have a demo with what we're doing jointly with Celona and Palo Alto Firewall and the IoT platform integration. So let me start with the Zero Trust Network Access. So one of the things that our customers have been actually asking repeatedly is they have a common authorization platform in the enterprises, whether it's a Cisco ICE or it's the Aruba ClearPass or any other radius servers that are common in the market. So the big ask from our customers were, how do you actually bring private 5G, private networks into that authorization tool? And that's what we have done as part of this. This is actually a roadmap feature. This is coming in the month of June, and I'll actually walk you through a remote demo for this. Specifically for the demo, as you can see, as Mehmet was talking about the solution, the users and the access point, the authentication still happens with the Celona Edge. The authorization gets passed to the ClearPass server for any authorization, or either it's a device, IMEI, or whether it's the MC, the user information. Okay? So let's jump straight into the demo. And again, I don't have that live here, but I have a screen recording of that demo. Coming in 2406 in the June release, and we are doing it on an edge cluster with the Celona Edge. The first thing you'll actually see here is the device authorization. Once the device authorization is turned on, once a device authorization turns on, it actually pops up what radius server do you want to connect to. And all you have to do is enter the information, the username, the credentials, the port that you want to connect to. And more importantly, from a Celona perspective, we can actually authorize the device either at the IMEI, the cellular IMEI, the device level, or we can also authorize based on the MC. Yeah.
Does that work with only your SIMs, or?
Right now, it's with our SIMs, electron eSIMs. Yeah, with our SIMs and eSIMs.
Why would you need anything other than the IMI? Since every client that's on your system is on your system and has one of your SIMs.
Sometimes some of the enterprises want to have the granularities like a user versus the device. So that's what we have seen to get the request.
So the user gets associated and gets connected, and then the user name and password gets sent over a radius.
Correct. That is correct. Yeah. And we can actually just.
Sometimes there's a concern about if it's a physical SIM, what if someone takes that SIM and puts it on a different device?
Yeah.
Yeah, sorry.
Just leave it on.
Okay. So the point was, as a security feature, let's say the SIM card is in a camera, and sometimes there's a concern, someone physically picking that SIM card and putting it in their device, and then you don't want that device hardware to connect.
Yeah.
Thank you, Mehmet. So on the device side, so by default, the user or the device comes in, he'll be in the default group within our Edge cluster framework. So we have introduced a concept of configured and connected. So basically, if the configured is default and authorization is turned on, he gets the authorization from the radius server, which we'll go through in a minute. And whatever profile is defined on the radius server, it gets applied. And you can actually move the user from the default group to the different group. I'll show a demo where we are actually moving from a default group to a connected worker group. So just to quickly go through the configuration, the ClearPass Policy Manager, in the landing page, you define the services. You can actually import through a CSV file or an API all your devices. It can be based on IMEI or MC. Import them. And then we define an Celona enforcement policy. And once it goes through the profile, this is where we actually tie the radius request to the default to the connected worker group. So in this case, we can actually see the device actually comes in. It wasn't the default group to begin with. Any new session, any new request comes from the user. So we actually toggle the font, from the airplane mode to off, on to off. Once you toggle, the new request will actually come in. The device gets connected. The new request comes in, and slowly you can see the connected group moves from default to the one that is basically sent from ClearPass.
Okay, so you got to trigger that, right, by airplane mode and back.
Yeah. So think about some of the devices may actually go off and they come back. When they come back, reattach to the network, that is when it gets
the policy is applied at
policy. Yeah.
At the point of attach. Okay, yeah. So there's no concept of COA or anything like that. And
absolutely. So in the concept of a COA, what happens is the change of authorization happens. The change of authorization moves the profile in ClearPass from one to the other. He sends the request API to Celona. We clear the cache.
Okay. Sorry.
Yeah. Any subsequent request that is coming in, that it will actually go into that COA mode.
Okay.
For example, if somebody moves from operations to engineering, anything from the authorization will change for the role.
Gotcha.
We also will support the DM, the disconnect messages. So in that way, the authorization profile will be completely removed, and that will actually turn an API request to us. And we'll clear the cache. And the next time when the request comes in, he will not be authorized. He or she will not be authorized. Okay. And keep in mind that we have to actually define in our IP domain, we have to define whether it's connected worker or whatever the roles are. Radius gives you the profile, and we apply that profile on our Celona edge. Now you can actually see the connected worker. It's tied to the IP domain, connected worker domain, and slowly as things come up, and this is where the external IP domain where we define the connected worker domain or any of the domain on the Celona edge side, and the user gets authorized. We put the user into that IP domain. Okay. You can see the device moves from default to connected worker already, and everything is good as op. So let me just go back into my slide. A couple of things I want to just talk back. I'm not showing a demo on the change of authorization, but the change of authorization works very similar to that.
Oh, look right there.
Yeah. So if there's no change of authorization, then any request comes in, the request is cached. So any subsequent connect or reconnect happens, you don't have to go through the authorization. It's basically cached until triggered by a change of authorization or a disconnect message from the ClearPass.
How many clients can you cache authentication for?
I don't think we have a scale issue with we have thousands.
Okay.
So yeah, we do not have a scale issue. Thank you. Okay. And right now we are showing the demo with the ClearPass. There's nothing that's actually stopping us from it could be any radius server. So we have tested, validated with ClearPass. It could be with Cisco ISE. It could be with Fortinet. It could be with any policy management tools out there.
So, quick question on this. Looks like you need a physical SIM for a device to work. So I assume the phone has to be CBRS compatible, or if it's a computer, a Chromebook, or anything, or how else can you join?
Yeah. So in fact, this phone right here, it's an iPhone. It is connected by a eSIM.
eSIM, okay.
And it is provisioned by MDM, and that's one of the demo. We actually have a AirWatch MDM that's actually provisioning these phones here. So we support physical SIM, embedded SIM, as well as the embedded SIMs are all provisioned by MDM tools. And what we have tested and validated with JAMF and AirWatch, and our customers are using Intune as well.
But then any tablet or computer or Chromebook is going to need an LP.
Right. This one needs physical SIM. Yeah, this one is specific
Yeah.
because it's not.
But maybe
Also, it needs to
just,
support like band 48 or N48 also.
Yeah.
right?
yeah,
all of them.
I mean, you need the cellular support, right? You need the like cellular chipset in the device. But I mean, more and more the devices have that. Lots of tablets, handhelds, even now laptops are starting to come with the cellular support. Now, band 48 is a specific band in US, but pretty much all the devices support it because even operators like Verizon and others are using the band.
So if you provision that SIM on that tablet, can you move that SIM to another tablet and it will work, or it has to be provisioned on the device?
So to answer your question, so we have a SIM lock feature. If the SIM lock is enabled, you are tying the IMEI with the SIM, so you cannot move. But if the SIM lock is disabled, you can move it from one to the other within the same customer.
So we give that option to the customer, depending on what they like to do. If they want to tie it to the device, they can tie it. If they want that SIM to be reusable in many different devices, they can do it.
And you're tying that to the, was it ICCID?
ICCID.
ICCID.
That's right. Yeah, exactly.
Sorry, go ahead.
Not quite.
Oh, I was just saying that devices, I've run into these limitations, right? Sometimes, like not all devices, even though B48 and 48 is enabled on it, it's not gonna work on like network, right? So, what is that? What's the limitation? I guess I'm trying to understand always why is that, or how.
The SIM is what really, like, as I showed, right? When we provide the end-to-end solution to a customer, we not only provide the APs and the edge and the orchestrator account, but also the SIM. So the SIMs are pre-provisioned for that customer.
Right, but if I take your SIM and I put it in a device, for example, that is like not listed as one of your certified devices on your website, right? That's not going to work. I've run into that couple of times. And then that requires like the time sending it, back to Celona and all that, and getting through the certification process. Just trying to understand the limitation behind it. Like, what's the reason? Is it something that you have to?
No, we don't have to do anything. We don't have to do anything to the device.
Okay.
What the device needs to do is it needs to support the band,
Okay.
and that's the main thing. So we have. It's a standard feature, but it's like the devices support many bands, and most of the devices in US support band 48, but there may be few older devices which may not support band 48. So as part of our device certification program, we just make sure the device works as it is designed. But you may run into some corner case, some device maybe that has not, this feature has, the band 48 has not been enabled yet, right? That's still a possibility, but the vast majority of the devices, we have no issue, honestly.
Okay.
I know Hugo wants to go with his demo, so maybe give him a chance. Yeah.
Quick question. How much of this is being driven by IoT security priorities?
The
enhanced features, the firewall features?
I would say it's mostly driven by enterprises. So today, enterprises, they have iPads and tablets, whether it's for the connected workforce or whether it's for the an IT team. And they want to actually have common tools that they have, whether it's an MDM tool or an authorization tool or Palo Alto. They basically want to leverage that and use extend it for from the wired Wi-Fi to the private network. I would say that's what we are actually hearing from most of the companies.
Okay.
Are you sharing it? Maybe you should start.
So, we are very excited to have Palo Alto join us for a very cool demo. And before we start the demo, just want to quickly introduce the two companies that are working together to address some of the key challenges. The first challenge is the cellular devices. They come with the IMEI ICCID constructs. How do a SOC or a security operations get the visibility down to the IMEI ICCID beyond the IP address? So you can actually go down to the device, and not only the device. If there are devices connected, like an IoT gateway, if there are devices connected behind, we get the complete visibility and analytics with the joint integration that we have done. The other thing is IoT devices, OT devices, IoT devices. They have very, very poor security stack. There's a lot of vulnerabilities. We get that back, and we will be able to enforce it right at the edge of the network. Enforcing the remediation policies at the edge of the network is powerful. That's what our customers are working with. So thank you. Hugo, take it over.
And this is about extended zero trust. Zero trust is a concept, big concept that essentially has all those questions which are the right side: the when, the what, the why, the how, all these kind of questions, right? So everything is unsecure unless you can prove that. Pass all those questions. We are very confident and very familiar with wired networks, with the Wi-Fi networks, and I guess you are. But when you move to cellular domains, there is a little change there. What kind of changes, for example? Well, there are devices that some of them have users, some others not. For example, a laptop has a user, but a sensor may not. Every device has different use cases, so it gets super complicated. When you add the 5G or 4G layer, it just extends the coverage of the type of devices and also the problems of security problems, right? So when we talk about 5G, we can solve all those questions except the last one. Who? Why? Why we cannot? It's not that straightforward. In traditional networks, we are used to, if you set the first column, there is a device identifier. You have the MAC addresses, you have the IMSI, sorry, the IP address, and so on. But in 5G, the IMSI, sorry, the IP is ephemeral, so it can change anytime. And you can try yourself, reboot your phone, you will get a different IP. So it's going to be difficult to track you. Also, there is no MAC address of the phone when it connects to the cellular network. It doesn't have like a MAC address. It has a different hardware identifier called the IMEI or PEI in 5G. Also, for the subscriber or the user identification, in wired or Wi-Fi network, we use LDAP or Active Directory, whereas there is IMSI, and the SIM card itself has an identifier. So we cannot use definitely LAD. We can use it on top of the actual SIM card, of course, like additional, like the feature that you just mentioned. But when you want to enforce security and solve the problem of the who, yeah, you cannot trust just in that single, not the IP, not the MAC address. You need to trust in real 5G identifiers. Again, 5G means 3G, 4G, 5G. There is also another problem, which is segmentation. Segmentation, we traditionally we do VLANs, we do some nettings on those kind of things, and we try to space the different user by segments, right? Here in the cellular domain, what it goes in the core network is actually an APN or network slicing that can be translated to or connected to a VLAN. Celona does very well. And that's the way it's segmented, right? So this is kind of the difference and the problem why we need to tackle the who of the zero trust problem. So I have a demo for you. This is 4G 5G demo. It looks a little bit busy, but I can tell you, like, at the blue boxes, we have the Celona equipment. We have the square here is the Celona Edge. Then the Celona IPs, like you have over here. And you have the Celona orchestrator in the cloud where you connect and do all your configuration and monitoring. In addition to that, the Palo Alto components is the next generation firewall, which is on premises. Then you have an element security orchestration and automation remediation talking to Celona orchestrator. So this box over here, the XOR, is talking to Celona orchestrator in order to get all the subscriber context, which means the IMEI, the IMSI, the IP, APN, everything that we can have in order to enrich the who. Once we get that who, we need to enforce the security, have the visibility of the traffic, and enforce it. That's about the network. So what are we doing in the demo? So we have here some routers, 5G routers. We also have phones, tablets, smartphones. These are connected via the 4G, 5G signal to Celona. But in the back, they are tethered. And this is a very typical use case, especially in the industry. They are tethered via, in this case, it's Ethernet. It can be Wi-Fi as well. So we have some devices over there. Particularly, we have OT devices. So this is actually a factory environment. What do we have in the factory environment? We have a PLC. If you're familiar with the factory components, OT components, we have this PLC, which is no other than the brain of the factory process. He received information about sensors, send commands, give you the information, updated information of the status of the variables on the process, factory process. And here we have this PLC. It's an simulated PLC. It's an open source software, but it's sending the right protocol. It's Modbus TCP. But who is talking with? So this device is talking to this other part at the bottom. What you can see is a factory. In the factory, we have a motor and we have sensors, and we have many other things. This kind of protocol, Modbus, or this communication is low latency. Sorry, it requires very strict latency. It's very low throughput. But if you it's like you need to have low packet errors in here. Otherwise, the process will just be a disaster. So this is kind of the demo environment, but we also have a third one that we don't like, is the bad actor, the hacker. So everybody knows about security when something bad happens. Otherwise, everything is good. I have to say that all that communication, if you see the yellow line here, that communication is not going to internet. It's locally in the factory. It's not going anywhere. It's just local. What means that if if the firewall is not deployed in this part, which is the access part, we won't see it. Usually those firewalls are deployed in the perimeter outside to avoid intrusion like DDoS attacks, any other intrusion outside in communication, which we are as well. We are over there protecting that part. But if the traffic is inside, then we need to look at this, and we are going to see that in the demonstration. The first part of the demo is the visibility, and I have a video for you showing the visibility. So this is the Celona portal where you see all the devices that are in the inventory. If you scroll down, just go. Then you can see individual devices and the status, the IP address that it got, the IMEI, the IMSI, ICCID. If you click on it, it will be a lot of information about it. This information is very rich, and we are getting that information to our platform, to Palo Alto. How do we do it? We have the APIs, the open APIs that they provide. So we are sending those almost real time and getting that information, which we call the subscriber context, and apply it to the firewall. And now you can see this is the firewall page. This is where you see all the logs. Who is creating those sessions? Where are you connecting? Who is downloading viruses? Who is connected to social networks? Everything you will see over here. And usually you will see IP addresses, right? Like we have in this case. We have IP addresses of this subscriber here, the source, and where it's going and what application is sending. Like in this case, there is someone with YouTube at the right. There is a like. Is doing YouTube. Okay, that might be allowed, but you may restrict that as well. That's the typical firewall or next generation firewall. But we do something else. We get that subscriber context. Remember, if that firewall IP changes of the user, the security information might change. So the first visibility we're getting, if you see these two columns, are the IMSI and IMEI, the subscriber identity and equipment identity. Yes, we solved the who. We know now who is doing that traffic. What if this device reboots, gets another IP? We still know who is, because we know the IMSI and the IMEI. So that's the first part of the demo, is the visibility, right?
Can you create policies within Palo Alto to block based upon MC and IMI?
We're going there.
Awesome.
Excellent question. I love
Glad
it.
you. No, probably not.
So, and I want you to remember this diagram very well because we're going through the demo. We're going through here. So every DG or cradle point or every device here has an IMSI and MEI. But the guys behind, they don't have IMSI. They are traditional Ethernet, they really have MAC addresses. And they might do DHCP, right? So we need to have that visibility of the devices which are behind. And we are getting that visibility. We can block uncontrolled those thanks to the super netting feature in Celona.
So you've got IP addresses on there. They're in different subnets. Are they getting those from the Digi devices and the cradle point, or are they getting them from someplace on Celona?
So they're both kind of things. So if, for example, the one in the middle, the device in the middle is a device that is doing nothing. So it's serving as DHCP server. Okay, so it's the only DHCP server providing the IPs. Whereas the DG, which are at the top at the bottom, they are not doing nothing. They are relaying DHCP towards Celona, and Celona is relaying DHCP to our firewall, which is a DHCP. So that DHCP service goes all the way to the bottom, goes back, and we can, in this case, the customer can allocate the IPs however they want. If it's
so you just mentioned this thing thanks to the supernetting feature, right?
Yep.
So again, to extend on his question, you're saying it only works with supernetting feature, or it will work either way?
It will work either way.
Okay.
Yeah.
Yeah.
But I think that maybe the key aspect to jump in here, because I think this is really key. I mean, the first thing we do, like, is table stakes for folks like you, is for the enterprise to be able to assign IP addresses to the end devices. Believe it or not, most vendors don't even have that capability. So that's, of course, we have to do it. We have been doing it. Now, the next level question is, if the end device, like the PLC, is behind a 5G device, like on the top, now we want to have the ability for the IP address to that end device to be assigned through the DHCP server. And then we act as a relay in our Celona side and then work through that IoT gateway like Digi so that we enable that end device to get an IP address. And that's the super netting feature. That's even an enhancement on top of the standard.
Right. Yeah. No, I just wanted to make sure that the Palo Alto will work like whatever you were showing, whether we're doing super netting or not. Either way it will work.
So yeah, to answer your question, it will work. However, it will, if we insert, you see the point number 2 in red, once we see the traffic there, if it's super netted, the device is super netted, we will see individually the source IP address of the actual device, not the DG. Because if it's netted, all the traffic of what is behind will only have one source address.
Right.
Okay? So they are different.
Yeah. Okay. Yeah. That's fine.
So this is the context, and I will go again now to the fun part. I told you it's a factory environment demonstration. Okay. So here at the top left, we have 2 windows. At the top left, we have the PLC. We have the PLC in here. And on the right side, we have the factory environment. Here in the factory environment, we have 2 elements, a motor and a laser sensor. The PLC, which is in the other DG, connected via 5G, sending commands to the motor and reading the sensor information. Everything through the Celona network. Oops, sorry. So what happens is that there is a conveyor belt. You see that conveyor belt, and there is a basket. When I put the basket at the beginning, it just runs the program. The PLC has a simple program saying, if the laser sensor is on, just run the conveyor belt. And then you have your basket moving away until it reaches the sensor. And remember, this all packets, Modbus TCP, is very low latency, very latency intolerant. So they need to guarantee those packets to arrive. And this is perfect. This is the good part, right? No security problem. We can see those traffic over here on the firewall. You can see that part, but guess what? There is the fun part. There is a hacker. For some reason, that person managed to get into the IT from IT OT domain. Again, there has to be segmentation for sure. But if they manage to succeed to access, especially OT devices, some of them are very vulnerable. then the hacker can come in, and then that's the hacker in action. You just put in an exploit and look at the box over there. And it's just a box. What if this is a robotic arm or a nuclear industry or any other thing about it? So what happens is that kind of disasters can be, you will lose something, at least money, because of the factory process, but there is a problem of fatal safety issues if somebody dies or, big problems. Hopefully it doesn't happen. So we need to avoid these kind of things, and the industry knows this. So how this can be prevented? By ensuring that the right devices do talk the right application, layer 7, to the right devices. So one option is to applying security policies. Yeah, of course you have to have cementation. That's the first part, but you need to enforce security policy, the question you asked. So let's do security policies based on the IMEIs. So that's the IMEI of the bad actor. The Security Operations Center already found out the log of the intrusion, and let's create a policy banning the right capabilities from that specific IMEI. So here is the configuration in the Palo Alto. You define the source IMEI, or you can define the source IP. As you know, the IP may change, so we trust more on the IMEI, or maybe on the SIM card, on the IMSI. This is the application that we are banning, and then just commit the configuration.
Wouldn't this block everything behind the cradle point?
No, just that
He's
application.
blocking the.
Just the Modbus write commands. Yeah.
Okay.
So it's a layer 7 firewall. So we look at inspect the traffic, and we look at the application.
Next generation.
So you weren't blocking the IMEI, just something that is the source from there.
Yeah. So we're blocking the Modbus application writing from that IMEI. Yeah. So now let's run the process again. It's a bit slow. Yeah. And you can see at the left, these green buttons which are there, these are the PLC, states of the conveyor belt and the light. So it stopped then. The hacker came again. Oh, let's try again.
I want this box to fall.
Let's try again. Uh-oh, doesn't work.
Being denied.
They are restless. I mean, they would try any other way, but
And this will, I guess, will show up obviously in Palo Alto and everything.
yeah.
Is there? I guess it's through APIs, right? With Celona, right, in Palo Alto.
APIs is getting that subscriber information, the context, the
Right.
first part, the visibility.
Okay. Is there like a separate licensing or something like that, or is it just like if
No.
I have a customer that's using Palo Alto and they already have this, or?
So that's a very, very good question. So existing customers, that's a general thing, and you might know this. Whoever is doing now having Ethernet, Wi-Fi, and they're looking to move to cellular, they already have a security infrastructure in place. They want to handle that security the same way they used to do before with the Wi-Fi and wired infrastructure. So what we're doing with this is just extending to the cellular domain,
Sure.
the same way they used to do. So if they already have a firewall, next-generation firewall, just enable this kind of things and no license.
Can you go back to your picture, your diagram of all the parts?
Yeah.
And the question is, how is what's the mechanism at 2?
That's the firewall. That's
The mechanism there. So
No, so your firewall's
Between the
someplace
Celona
else.
IP and Celona Edge.
Your actual physical next generation firewall.
It's the yellow box.
The little yellow box.
It's the yellow box.
is the yellow box.
What is at 2, or is that need to be redrawn to all the traffic goes through the yellow
Shouldn't
box?
that yellow box be where the number 2 is?
Yeah, shouldn't it be
Yeah.
in there?
So actually the box is next, but if you can see there are some lines
Inline.
here.
Yeah.
These actually connect the logical connections.
Inline.
So I may put 2 yellow boxes, but
So how do you know of all the traffic that's going past the Celona AP, are you looking at all the traffic?
Yes.
Are you physically in between the two?
Yes.
Yeah, the traffic is going through the firewall.
Yeah. So shouldn't that box be over there?
But then
Right,
it's
no,
not
the firewall is not in between.
Oh,
It's tapping. Right?
it's
Okay.
It can be depending on the customer requirements. It can be in between.
Not-
It can be tapping,
not
like
physically.
just hearing,
Yeah.
because they might
tapping.
have just
Okay.
alerting.
That was the answer I was looking for.
I
Okay.
do have a question on the policy because you did a specific deny policy.
Yeah.
If you've got the IMEI and MC, could you then create use like a user ID policy on the firewall
Right.
instead, and
Yes.
just say only these users could be allowed to do this
Yes.
command?
So the concept of user ID is like a single device that can have, or person that can connect in different devices. Say a laptop is, I can use my user ID, my phone, I still use my user ID everywhere where I go.
Mhm.
So that communication or that, say, correlation can be done. So from the firewall, we can tell XOR, hey, by the way,
Yeah.
this person that has also that these these identifiers. So build it on top of the user ID.
Yeah,
Right?
because you're
So-
you're here. You're just doing the device.
Just the SIM card or the
I mean,
IMEI.
if someone had the ability to do that right command, I would assume there had to be some user authentication behind that as well.
There might be the case that
Yeah.
just bypass the user authentication. Yeah, I'm skipping the part where the hacker jump in the network,
Yeah.
right? So, but if they happen to succeed, these are the consequences.
So where does XOR play into this then?
So XOR is, in this case, is talking to Celona
Uh-huh.
to get talking that API, get the subscriber context
Okay.
in order to do the visibility.
Okay.
After that, we run autonomously the second use case, which is enforcing the security, doing the policy, these kind of things.
Okay, so that goes to your question about the licensing and subscription. The XOR is separate.
Excellent.
Yeah,
from
it's
Separate.
the
Okay.
firewall.
Separate. Yeah.
exactly.
So it is then needed. I mean,
You need XOR.
Okay, so there was no problem. So the factory was okay. And then to answer your question, here we can see that there was an attempt to access. So we're good.
On time, yeah.
You want to just quickly show the Celona orchestra
Okay,
the policy we implement.
that's it. So the third use case is about security automation. So yeah, the firewall blocked this, but hey, who prevent that the hacker goes in a next or different jump to different place? So the first one can be an alert to the customer that we need to do something and stop things. And that's why we also have a use case called security automation. And security automation used against XOR to talk to Celona, but in this case, it's XOR telling Celona. So in this case, like this operator, which is also having a smartphone connecting the same private network. So see, you can connect your OT devices, but you can also connect your employees, your operators with a 5G network. And what happens is this person just download a malware, click a phishing email, and then the hacker got access. In this case, the next generation firewall will detect the problem and will tell XOR, and XOR will send the API to Celona, like a security event report, and Celona will trigger an action, a configurable action, which can be quarantining or can be disconnecting completely from the network. This is a playbook that runs in XOR, completely configurable, like the operator can decide what to do when they find these kind of problems, or alerts and emails and texts to the security, the IT personnel. And let's run this quick demo. So this is the person with the phone, is doing regular web browsing. Everything is configured on the firewall, doing threat prevention. And then on Celona as well, we have the configuration for compromised devices. Then the person receives an email, those kind of emails that say, click here, urgent, change your password now. And then the hacker tried it, but the firewall detected that. and automatically alerted XOR, and XOR told Celona there is this problem. I'm just showing here how it looks in the playbook. And then, of course, there is a person there, the Security Operations Center, which, okay, we need to take care of this, or taking notes. We need to put antivirus, or maybe, let's isolate completely. But over here, if you can see, there is a quarantine. So this device went to quarantine, to the quarantine device group, which means it's still connected, but it's limited in traffic.
Mhm.
But what happens if everything was clean, updated the phone, cleared the phone, very good, it can go back to service. So you can also do that, the same thing, and then the rollback, and then the device can get online.
It was quarantined automatically or manual? I missed that part.
That was automatically.
It was automatic.
So it's an automation playbook.
Okay.
Firewall detects malware, sends to XOR, XOR sends to Celona,
Okay.
and Celona takes the action on the cellular network.
But there's no reconnecting of the client needed. It's an inline action.
Yeah.
It's an inline quarantine.
Yes.
Right. Okay.
So, and the firewall is not a network function in the 4G or 5G network. It's like a security element, right? We cannot talk to straight to the access points or straight to the core because we are not 3GPP equipment. But we can tell them via the APIs what action can they do. Yeah.
Okay.
Well, that was it. Thank you very much.
Yeah.
Voila.
Thank you.
Thank you. Just like the change of authorization, any change it's instant enforcement and enforcement at the edge of the network.